We're going to continue taking a look at characteristics. This video is going to cover domain and range. So what is domain? Domain are X values only from left to right. So this is the notes on how you do that. It says sketch only the graph and the x-axis. All right, so sketch only the graph and the x-axis. So I'm going to do these notes on the side right here, and I'm hoping that this would make it really clear for you. Please feel free to add on any additional notes just for clarification purposes. So it says sketch only the x-axis and the graph. So that's the x-axis, and I'm going to make the graph a different color just so that you know. All right, so that's what the graph looks like. All right, so this is the x-axis. Write down what is the most left part of the graph. Okay, so if you're looking at the graph, and remember the graph is the line, you'll notice that you see some arrows here. What those arrows mean is that it goes on forever in that direction. So this goes on forever in this direction. So the most left part of the graph is not here because it keeps going on forever this way, correct? So that way the most left part of this graph is all the way here. What is the largest, most negative number that you can think of? Negative infinity. It is not quite a number, but it is a representation of the largest number that you can think of. So it says write down what's the most left part of the graph, which is negative infinity. All right, leave a space and write down what's the most right part of the graph. And what's the most right part of the graph? You can see that this graph also goes on forever in this way. And therefore, on the x-axis, those numbers are going towards where? Positive infinity. So the most right part of the graph is positive infinity. So I'm going to go right here. I'm on the linear parent. I'm going to write negative infinity, leave a space, and write infinity as instructed. Then it says copy the same thing on the other notation and ask if it's open or closed. Okay, so I'm going to copy the same thing, leaving a space, and ask myself if it's open and closed. So let's define some open and closed. All right, so if it's open, you don't include it. Also represented by an open inequality. And the difference between an open inequality and a closed inequality is that it has the or equal to underneath it. If you see it open, it means that it is a parentheses. If you see it closed, this is what I'm saying, closed, you're going to see that it is a bracket, or you will see a shaded dot. So if it's an open dot, it's open, a shaded dot, it's closed. And the representations in our notation is going to be a closed bracket if it includes it, an open parentheses if it doesn't include it. So there are two different types of notations that we're going to take a look at. You're going to choose the one that you're most comfortable with, but you do need to be able to recognize both. So interval notation is going to be what we just talked about in terms of parentheses and bracket. Now, do I include negative infinity? In other words, is there a point on negative infinity? No, and that's because negative infinity or infinity are not actually numbers. They're representations of a very, very, very big number if it's positive, or a very, very, very small number if it's negative. So these do not include, so we are going to go with parentheses, and then you just put a comma right in between them. So this is going to be interval notation. So interval notation is going to be talking about open and closed parentheses. Set notation is going to be talking about inequalities. If we're talking about domain, which axis are we looking at? We're looking at the x-axis. So the letter that has to be between these two is the x. In terms of the inequality, it's always going to be facing this direction. Now, if it includes, just like we talked about right here, if it includes, we're going to have this or equal sign. If it doesn't include, there will be no equal sign. So because this does not include, there is no equal sign underneath it. All right, so these are the two notations. Whichever one you're most comfortable with is what I'm going to ask you to keep. So it looks like the domain for everything, all the graphs up to exponential, goes to negative infinity and positive infinity. Another way of representing this that I want to make sure I cover is what is called all real numbers. It looks like a capital R with two lines going through it. It means everything you can think of from left to right. Every number, every decimal, every fraction, every radical, just anything you can think of in all eternity, from all the way to the left to all of the right. So it's another way of representing negative infinity to infinity, all real numbers. So there's only really one that you're going to find, which is the random one. And keep in mind for the random one, all right, so again, domain is from the left, right? From the left all the way from the left, all the way to the right. Keep in mind when you have this closed, all right, so we talked about that definition. Closed means include. So for interval notation, you will use this closed bracket. And then when you have this open one right here, right, open one, it means don't include. So here you'll have a closed bracket, then the two things, and then an open parentheses. All right, so go ahead and give that a try. So the next thing we're going to take a look at is the range. So domain, we're looking at our X values, and X goes from left to right. You're going to draw a horizontal line, right? But when we're looking at range, we're looking at our Y values. So Y values is from the bottom to the top. So it says sketch only the graph and the Y axis. So again, I'm going to go ahead and sketch the graph. So this is the Y axis. I'm going to label it Y. I'm only graphing just the Y-axis so that I know that I'm only looking at those numbers. This is the graph for the linear parent, so that's this one right here. And then you're looking from the bottom of this, which is right here, right, to the top, which is right here. Now, the thing is, this arrow represents what again? That it keeps going. So this is really not the bottom. So -6 is not the bottom because this arrow keeps doing what? Going. So where is the bottom? Where does this arrow keep going towards? -infinity. So this keeps going to -infinity. And on the top, because it says from the bottom to the top, it does not just go to 6. Why? Because there's an arrow going on forever. So this numbers are going up to what? +infinity. So again, just like we did for domain, you're going to leave a space, write down the bottom and then top. And that has to be that order. So it has to be the bottom number, then the top number. And then you're doing it in both notations. The bottom number was -infinity. Leave a space, +infinity in both notations. If you're having problems with writing infinity, turn your paper around and write the number 8, and you'll see that it's infinity. All right, so I've written it in both notations. The second question I need to answer, so I got my two numbers. I need to answer if it's open or closed. Now, we've talked about infinity being what? Open, so we do not include it. So in interval notation, remember we're talking about either parentheses or bracket. It's going to be parentheses on both because it never includes that. In interval notation, you have to tell me what axis are you talking about. So for the range, I am talking about the Y-axis. So if I'm talking about the Y-axis, the letter that has to be in the middle is Y. And again, in terms of the inequality, they are always facing this direction. Now, the question becomes, do I include it or don't I? So again, I'm not including a -infinity and +infinity, which means they should not have an equal sign because this is don't include. So pick the one that you like, either interval or set, and go with it. All right, so I'm going to go with the quadratic one. And again, following the notes, it says draw the Y-axis. So I'm going to go ahead and draw the Y-axis. This is for the quadratic. Then it says draw the graph. So I'm going to go ahead and draw the graph. It looks like a U, like that. Okay, then I'm going to look from the bottom to the top. And again, I'm just reading the notes here. So write down what is at the most bottom part of the graph, what is the most top part of the graph. Okay, so taking a look at, so where is the most bottom part of the graph? We can see the most bottom part of the graph is right here. There's nothing underneath here at all. The very bottom of the graph is right here. So I'm going to go look on the graph. Only on the Y-axis, that number is going to be 0. So the most bottom part of the graph is 0. And where is the most top part of the graph? And again, I am tempted to say that this is the top of the graph right here. Right here is the top of the graph. But remember, if you have arrows, what does that mean? That it goes on forever in that direction. So it's going on forever to the top. To what number? To infinity. So my two numbers are 0 to infinity. Now remember, you must go from the bottom to the top. So 0 to infinity are the two numbers that I'm going to write. So 0, leave a space, infinity. 0, leave a space, infinity. Because I'm talking about the range, I'm writing Y. All right, then I'm going to draw my two inequalities. They're always facing that direction. Put my comma right here. And I just need to know if it's open or closed. Well, we know infinity is always open. So this is open. All right, now Y is 0 closed, which means, is there something at 0? So if I look at my graph right here, is it shaded? Yes. So it doesn't necessarily have to be a dot, like a big dot like this, because a line is made up of an infinite number of dots joined together, and that's how it becomes the line. So this really, it ends up looking like a line, but it's really an infinite number of dots. So yes, it is shaded. In other words, Down here, what you don't see is you don't see this. Now, if you see that, it's open. So in this case, it is closed. And remember, closed is a representation of a closed bracket. And if you're doing it in set notation, you must have the equal sign underneath. So this is going to be a closed bracket. And I'm going to put an equal sign underneath representing closed. We're going to take a look at an exponential parent. Okay, so again, the notes say, go ahead and sketch just the y-axis, the axis that you're looking at so that you don't get confused. Sketch the graph itself. So I'm going to sketch the graph itself like that. Okay. And then it says go from the bottom. So I'm going to highlight the bottom. This is the bottom right here. Right there is the bottom. So I'm going to look at the graph. Where is that highlight bottom? So what is that number? Just not on the x-axis. So ignore the x-axis, just these y-axis. That number is 0. So the bottom of this graph is 0. And then where is the top of this graph? So the top of this graph is right here. But remember, here we have an arrow. So an arrow signifies that it keeps going on. So this is not really the top. It keeps going on to what number? To infinity. So I'm going to write those two down. So again, I've got 0 to infinity, 0 to infinity, and I'm looking at the y. All right, I'm going to draw in my inequality because they always look that way. And then I just look as whether it's open or closed. So is the 0 included? Now, you may not know this. Again, I did mention this in an earlier video. This slide actually approaches 0 but never touches 0. So because it never touches 0, it is open. And remember, open is parentheses and no equal sign. So here I'm going to put parentheses and no equal sign there. And infinity we already know is open anyway because it approaches but never quite touches, never reaches infinity. So the range again is from the bottom to the top. Here's the y-axis, and then the graph, it looks something like, and it doesn't have to be perfect, whatever. And I'm looking for the bottom, so I'm going to go to the bottom. So boom, so I'm going to go right here and then go to the left. So if I go right here and then go to the left, what is that number? -9. And I'm going to write that number down, so this -9. And then I'm going to go to the top of the graph. Is this the top of the graph right here? No, this is the top of the graph. So that's the part I'm highlighting. So when I highlight that and I go to the top of the graph, which is at the top of this little hump or whatever, that's going to be -2. So I'm going from -9 to -2. So I write down my two numbers. So this is the random one. Space -2, -9, space -2. I'm looking at range, so my letter is Y. Okay, then I'm going to put my two inequalities, and now I need to decide whether it's open or closed. Okay, so let's take a look at it. The -9, the bottom right here, is it defined? Yes. If the bottom had this open circle, it would be not defined. So this is defined, so then it is closed. My representations for interval notation is going to be closed bracket. For set notation, it's going to be with the equal sign. So I'm going to put a closed bracket right here and an equal sign right there. All right, now I'm going to look at the number -2. All right, so that's this hump right here. So this hump right here, is there an open circle there? No, so then it is defined. So then this is also closed. Closed on -2. And closed meaning the equal sign on that. All right, please go ahead and practice this 3. The graph is already sketched for you, but just remember, hint, if given anything else but a graph, put it in Desmos so that you can see the graph. Let's practice.